Hi all. Today's lab which is experiment 3, is waveform measurements. In this lab, we will apply 3 different waveforms and we will measure them by using different equipment. So we will use 2 oscilloscopes, 2 digital oscilloscopes. The first one is Digilent scope, and the second one is Tektronix TBS 1102P. Also, we are going to use 3 different multimeters, digital multimeters. We will use Mastic MS8217, Protec B940, finally NSTEC 8245. So in this experiment, you will measure your waveform by using 5 devices. Here, the first one, we will apply the first part of this experiment. We will apply a sinusoidal waveform, just like this one, no offset. Then, as you know from class, your root mean square is the maximum times 0.707. And this is the average, maximum times 0.636. So when we measure the RMS, you should get like the peak or the maximum times 0.707. This is for sinusoidal. For triangular, the root mean square of the voltage is almost 0.577 of the peak, while the average is around half the peak. For the square wave, the root mean square and the average are equal and are equals, and they equal to the peak. This is for a square wave without offset. But in our experiment, we are going to apply a square wave with an offset. So let's see what we can get from that. So these are the effective values or the root mean squares for each waveform. This is for sinusoidal, this is for square wave, but be careful that you have an offset in your experiment. This is for triangular, this is for the poles, and this is crest average, crest value, and go on. So let we start our experiment. The first step is to apply a waveform. So we will use the Digilent board to generate analog waveform. So this is the analog wave generator. As it can be seen from this window, analog wave generator channel 1 is connected to the plus terminal. Here, because all these points are internally connected, so you can connect your device in any of these points, or what you can do, you can use as many meters as you want at the same time. So here analog wave generator is connected through channel 1. This is, the ground. So this means all the negative points are grounded so far. We should always remember to keep this port off while building. But here we just connect the analog. So we can turn this on. The first device or the first meter we are going to use is the Digilent scope. So we will jumper the analog wave generator which is any point from this, right? So make a jumper to the you have the option to choose any channel you want for this scope, but we can try to use because we are going to use only one channel, so let me work with channel 1 of the scope. Now let's go to the wave generator. This is your wave generator. Okay, the first signal, you can set this the first signal as described in the sheet will be a sinusoidal with 2 volts amplitude and 10 millisecond period or 100 hertz frequency, and there will be no offset for the first waveform. Okay, now it's disabled, so I have everything, and remember to make sure that everything is set right. So this is 100 hertz, this is 2 volt, this is 0 volt offset. Now it's ready to be run. Let me run it. Let me check. Now because we already made jumper from channel 1 to from analog wave generator channel 1 to the scope, this one. Now this is the first. Let me run it. It's running, but it's already been set before, so always try to use auto set. When you get any from the scope, always try to use auto set. Now, then when you use your auto set, you can see your waveform and you can apply with the time pace and the and the range to get a good shape of the input voltage. So this is your time. Let me go with this. Okay, this is good. So this means range is 500 millivolt per division. So every division here is 500 millivolt, where for the time every division is 2 milliseconds. This is our first waveform. Now what we will do, we will use this tool for measurements. Because it's a channel 1, and if what do you want to measure in vertical? We want to measure peak to peak, so choose peak to peak and add selected measurements. Also we need the amplitude, add selected, and we need DC RMS, add selected. We need AC RMS, add selected. As I can see from the sheet, peak to peak, amplitude, DC RMS. Okay, this is all for vertical. Now let's go to horizontal here and choose the frequency. Add. Now, as you can see, this is your peak to peak, this is your amplitude, this is RMS, Okay, so now there is a question should come in your mind. What is the difference between DC RMS and AC RMS? So this question has to be answered in your report. As it can be seen here, they are equals, but are they equal for all the time? This is the question. So, and look for this DC RMS, AC RMS. Now, we should table our results. So just like we can create this Word file, okay? This is, this file will be posted on Canvas under, let me say, Lab 3 supplement, okay? So you can use this in your report because you are required to see this video and get the measurements from the video. Then you can write your reports. Now this is our Digilent scope. What we got for peak to peak is 4.04 and our amplitude is 2.015. DC RMS is 1.425. AC RMS is 1.425. And you know, here as it can be seen, your frequency ranges from 99.9 to 100. So we can consider it 100. Okay, it's stable. This is the first one. Now, this is the first one. Now, let's use Tektronix. Let's use Tektronix. Okay, this is your Tektronix. Okay, and we should first turn on our scope. Wait few seconds till it starts up. Okay, we can save the time and connect the probe of this scope to the input signal. So this is the black should be connected any point here and negative. So this is ground and this is positive. Okay. First step is to do is offset always. Try. Okay. Now you can see the waveform from Tektronix scope. We can change the scale of the time here. So it's good. Let's keep this. And you should use this to measure then which channel we are using. Channel 1. So choose channel 1. What do we want to measure from Tektronix? Peak to peak. Okay. So scroll down to peak and click if it's unchecked. Okay. Frequency, yes, it's already selected. Channel 1. Channel 1 RMS. Yeah, this is RMS. And I have added more, which is maximum and minimum. Maximum is the same as your amplitude or your peak. Okay, 1, 2, 3, 4. Here in Tektronix, you can choose up to 6 variables to be measured at one time. So if you need to measure more than 6, you have uncheck and choose others. Okay. Now we can go to this file and write whatever we got from Tektronix. For peak to peak from Tektronix, it's 4.16, 4.16, and your amplitude, which is the maximum, 2.08. 2.08. Your arm here, it gives you AC RMS, which is 1.44. We will see it later. So that's why I don't want to tell you more, because I want you to look for the difference between AC and DC RMS. But here it's a AC. Okay. Now, as you can see, the frequency ranges from 100. It's from 99.8 to 102. So let me consider it as 100. Here, another thing for Tektronix you can do is, you can press on this. This is your channel 1, right? Okay. So just press on channel 1. After you selected all these measurements, you can click on snapshot, okay, and run snap. Here, as you can see, all the values give you the period, frequency. So we capture it for our frequency here. When we capture it is 100.1. 100.1. Okay. And our peak to peak, as it can be seen, 4.16, RMS 1.44. Okay, so these 4 Tektronix, right? What else? We will use 3 different multimeters. The first one will be Mastic MS8270, which is this one. Okay, this one. Now, let me connect this meter to analog wave generator through channel 1. So you can connect the red one to the positive, okay, and the black one to the negative or ground. Now, let me turn this on. How much we got? 1.424. This is your AC RMS. Here, as it can be seen, these digital multimeters unable to measure peak to peak or the amplitude. It only measures the root mean square or the effective value of either current, voltage, or any. So it measures the effective value. Okay. Now this is our effective value, which is 1.424. Let's move to an stick, which is this one. Okay. we have to connect this to, this is positive, red one to positive, and black to ground. And we should turn it on. Then we should choose AC volt. Okay. How much we got? 1.4236, which means 1.424 is almost, because I'm going to use 3D or 3 digits after comma. So let we consider it as 1.424. Okay. The last meter that I'm going to use is Protex P940. So red to the positive, black to the ground. Oh, okay. Now we should turn it on. 1.423. 1.424. 1.424. So almost the 3 meters are the same. 1.424. This is, can you see the port now? This is for the Tektronix. This is for Mastic. This is for Anestic. And this for the last one, which is Protec. So you can use many meters at the same time because you have a lot of points. That's why this is just, if you want to use more than meter, you can make jumpers because these points are internally connected. So if you connect just one, you can get benefits of others. Now, this is, I think we done with the first waveform, right? We done with the first waveform. Now, let's move to the second one or second part, which is a waveform, a triangular waveform with 2 volt peak and 100 hertz. So our offset will be 0. So this is the second one. We will use triangular with 100 hertz, 2 volt, 0, stop, run, check in the scope. Okay, this is in the scope. So what only you change and you will find all the magnitudes here. So let we record this using the specified table. For Digilent, we got 4.03, right? And our amplitude 2.015. DC RMS is 1.165 and AC RMS 1.165. So as it can be seen from sinusoidal and triangular, AC and DC are the same, right? Why? I don't know. You have to check. Okay, this one can be written 100. This is for Digilent. Now, let's move to let's use our scope. So, yeah, this is all these legal. What you can do, snapshot, right? So we will get all. Our frequency is 99.99.9. Okay, but first let we follow the table. What is the first? Okay, our peak to peak is 4.08. Yep, 4.08. Our amplitude is the same as maximum or peak, which is 2.04. 2.04. Then your AC RMS is 1.18. 1.18. Our frequency is 99.9. 99.9. This is for Tektronix. Okay. Go back now. Yeah, maybe you can choose, the measurements that you want by using measure which channel, and you can pick up to 6 variables to be measured. But here, if you just measure, this is for measure. Just if you can use this button to get all the variables here same time at one time, because it's already in channel 1, so it will screenshot or for all the variables in channel 1. Okay. Now let we move to digital multimeters here. Okay, they are ready. Now our RMS here is for mastic 1.11627. So 1.117. Okay, and for anesthetic, which is this one anesthetic, and this protect, this anesthetic is 1.161. 1.161. For protect is protect 1.163. 63, yeah. Okay, this is the second waveform, right? Now, let's go to the last one, which is square wave. Square wave, so we should go to here. So let me stop this. and we going to use a square wave with 100 same with 2 volt amp, but here you are required to add an offset of 2 volt. Okay, just run here. Now you can change here. So as you can see here, there is a one thing is not, yeah. So as you can see here, this question mark means this is out of scale, right? So you have to change the range or press auto set. Okay, so just we can leave this and write what we got. Okay, here from Digilent we got 4.06. This is your peak to peak, and your amplitude is 2.01. Okay, here your DC RMS is 2.85 and your AC RMS is 2. Now you can know the difference, right? There were equals in sinusoidal and triangular, but here in square wave we have added an offset. So please look for the difference between AC and DC RMS. Okay, when they should be equal, what does that mean? If they equal, what does that mean? Okay, our frequency is around 100. This is for Digilent. Now let's see what we can get from the Tektronix. Oh, yeah. Wow. Now we can write, or you can use that tool, which is a measure. We need snap. Okay. Okay. So our peak to peak is 4.60. See, 4.60. Our amplitude is 2.28. 2.28. Our RMS, AC RMS is 2.03. Finally, our frequency is 100. This is using Tektronix. Now, let's go to the digital meters. Oh, here your for mastic is 2.218. For anesthetic 2.008. 2.008. For Protect is 2.008. Okay. Now we done with these waveforms, but here let me check one thing. Okay, now as you can see in the sheet, there are, why mastic is not it will tell you that there are some meters not giving you the right RMS. Why? Because they only calibrated for sinusoidal waves. But here protects, because here when you see something like true RMS multimeter, so this means it will give you the right RMS. Okay, or this one is giving me the right one, this one is giving me the right one, while this one is not. This one is not. This one is calibrated just for sinusoidals. Okay. Now, there are some questions in the sheet have to be answered in your report. Okay. So, that's all for lab 3. We have, compared 3 different waveforms, and we have used 5 meters, 2 oscilloscopes, and 3 digital multimeters, Mastic, Anistic, and Protec. So this is all for lab 3. There are some questions, you have to answer them in your report also. This supplement, this table, you will find it on campus as lab 3 supplement. So this is the tables where you can present your findings. It will be found on campus under lab 3 supplement. That's all for for experiment 3. See you in experiment 4. Bye.